Arithmetic and geometric sequences. Do now. You work in a grocery store and are stacking apples in the shape of a square pyramid with 7 layers. Write a rule for the number of apples in each layer. Then graph the sequence. So to help organize this, we have a table with the layer number. So here's the first layer and the number of apples. So the first layer has 1 apple. The second layer has 1, 2, 3, 4. The third layer has 1, 2, 3, 4, 5, 6, 7, 8, 9. And the fourth layer has 16. And this pattern goes on until the 7th layer. So if you look closely, you can see there's a relationship between the layer number and the number of apples. And that relationship is that the number of apples is the square of the layer. So the rule for this example is basically the nth layer, the number of apples is n squared. And a rule for a sequence is defined as the formula in terms of n, which gives the nth term of a sequence. So if we take a look at example 1, write a formula for the general term of an infinite sequence. Now, infinite sequence just means a sequence where you see dot, dot, dot. It goes on for infinity. So we're looking for a pattern and a relationship to fit into one of these formulas. If you notice, the signs alternate positive, negative, positive, negative. The denominators are multiples of 5. And here are the nth term. Well, here's the first term, second term, third term, fourth term in terms of n. So what you could really do is go through here and just plug in, for example, 1 to each of these and see if you get 1/5 back. So if we take 1, well, first of all, let's look at the denominator. I believe in doing the easiest first. So we have 5, 10, 15, 20. We know that it can't be this because this is multiples of 7. It's got to be either C or D. So we plug in 1 and we get 5. We plug in 2, we get 10, 3, 15, 4, 20. So the denominators are both good. Now the numerators have to work out so that the signs alternate positive and negative. If we plug in 1, here we have n plus 2, so that's 3, and negative 1 to the third power gives me negative 1. As you can see, it's positive, so it can't be that either. The answer must be D. And we can check it just to make sure. If we plug in 1, 1 plus 1 is 2, so it's negative 1 squared, which is positive 1. And positive 1/5 is the first term. Plug in 2, 2 plus 1 is 3, and negative 1 to the third power is negative, and 5 times 2 is 10, so there we go. So in the first two examples, we looked at general sequences. Now we're going to specifically look at something called an arithmetic sequence. And an arithmetic sequence has consecutive terms that differ by the same constant called D, the common difference. What is the common difference in this sequence? So as you can see, we have a sequence here, and I've listed them in order vertically. And basically, the difference between each one, how do we get from the first to the second, second to the third, third to the fourth? We add 2a plus 3 each time. Another way you can find this is to basically subtract the second term from the first term. And as you can see, 4a plus 4 minus 2a plus 1, make sure we put this in parentheses, so we distribute the negative, gives us the same common difference. And of course, if you subtract the second from the third and the third from the fourth, it should always give you 2a plus 3. The other type of sequence we're going to learn today is called the geometric sequence. And the geometric sequence has consecutive terms that have the same ratio, and we'll use the variable r for that. So here's your sequence on the common ratio. Well, I've listed them again in vertical order, and basically ratio means division, right? Ratio means a fraction. So Or you could think of it as, how do we go from the first to the second, second to the third, in terms of what are we multiplying it by? Well, we're multiplying negative 1/2 times 4/5 to get negative 2/5. And negative 2/5 times 4/5 again to get us negative 8/25. The other way we could have done this is by dividing the second term by the first term. Negative 2/5 divided by negative 1/2, keep change, flip. Negative 2/5 times negative 2/1 equals 4/5. So here's your common ratio, 4/5. Check for understanding. Are the following sequences arithmetic or geometric? Then find the common ratio if it's geometric, and find the common difference if it's arithmetic. Number one, as we go down from 9 to 3, that's 6. 3 minus 1 is 2, so it's definitely not arithmetic. This is a geometric. I guess it could be neither, but this is geometric because as we go from 81 to 27 to 9 to 3 to 1, we are multiplying by 1/3 each time. So the common ratio is 1/3. Number two, here we have an arithmetic sequence, and we are actually going up by 6, plus 6, plus 6, plus 6, because as you can see, the negative numbers are getting closer to zeros. They're actually getting larger. Number three, a dead giveaway here is how it alternates from negative to positive, negative to positive. So you know the common ratio must be negative. This is obviously geometric, and it's negative 2, because negative 4 times negative 2 is positive 8. 8 times negative 2 is negative 16, so on and so forth. Number 4, this is, let's see, 26 down to 18, that's minus 8, minus 8, minus 8. So the common difference is negative 8. This is arithmetic sequence. Okay, the next two examples are kind of the most important of this lesson, because this is the takeaway. This is what you'll have to be able to perform on the Regents. The nth term of an arithmetic sequence with first term a sub 1 and common difference d is given by this formula. You must memorize this formula. It's not given to you on the reference sheet. So basically what that means is if you have a sequence, you know what the first term is, you know what the common difference is, and you're trying to find the nth term, in this case the 22nd term, right? N is 22, a sub 1, the first term is 39, and the common difference is, well, we're going up by tens. These three things can be plugged into this formula to give us the 22nd term, the nth term. So let's go ahead and plug into this formula, 39, 22, and 10, and it's just simple order of operations. As you can see, the 22nd term is 249. And finally, geometric sequences have a similar formula where the common ratio is r, n is the nth term, and as you can see with this example, what is the 15th term of the sequence? 5, negative 10, 20, etc., etc. Well, n will be 15 because they want to know what the 15th term is. A sub 1 is the first term, that's 5, and the common ratio, we'll have to figure that out. Let's see, we multiply by negative 2, negative 2, negative 2, so r equals negative 2. So all we do is we plug them into the formula. We can use a calculator if we want, plug it in. The answer, the 15th term of this geometric sequence is 81,920. Sage and scribe number 1. Here is a general sequence. It is not arithmetic, it is not geometric. So you're just plugging in to see which one gives you the first term back. When you plug in 1, if you plug in 2, does it give you this back? And the answer is A. Which arithmetic sequence has a common difference of 4? As you can see, the answer is 3. We're just adding 4 each time to get to the next term. Find the common ratio. As you can see, we are multiplying by 5/2 each time to get the next term. Find a sub 26. So as you can see, they don't specify whether it's a geometric or an arithmetic sequence, so we have to figure that out. And as you can see, these differ by 7, so we know D is 7, N is 26, and the first term, A sub 1, is 13. So we plug them in, we end up with 188 is the 26th term, which is the 7th term of this sequence. Again, they don't tell us whether it's geometric or arithmetic, but we can figure out because this one alternates negative positive. We know it must be geometric. They want us to find the 7th term, so N is 7, the first term is 2, and the common ratio is -5. Plug these into the formula. Use your calculator to help us out. 31,250. There's your answer, and there's a lesson. Good luck to you.